This video is on distance time graphs and how to calculate the gradient of a distance time graph. So you should have done by this point the equation for speed, which is speed is distance divided by time. So speed we measure in meters per second, distance we therefore measure in meters, and time we measure in seconds. So that's our basic equation for speed. Now what a distance time graph does is it allows us to show the how the motion of an object is changing with time. So we have on our axes time on the x-axis, which obviously will be measured in seconds, and distance on our y-axis, which should be measured in meters. So if you imagine I have a car that is stationary first. If I've got a car that's stationary, that means its distance that it's travelled from its starting point isn't changing. So on a distance time graph, a stationary object is represented as just a flat straight line. So this represents stationary, or stopped, same thing, or an object at rest. Now, if you imagine that an object is moving away from where it started, its distance is going to be increasing. So if I have an object that started at this point here, I'll call this point X, okay, and it's going to travel in that direction. Obviously, a couple of seconds later, once it's reached this point here, its distance is increased. A couple of seconds later, its distance is increased again. So as an object is travelling away from its starting point, its distance increases. And so we get a straight line like this. Now, you can see that these x's that I've drawn, if you imagine each of these represents a second, so this is 1 second, and there's another second, and there's another second, you can see the distance that they've moved is roughly the same each time. So this object is travelling at constant speed. So this line here, when you have a straight vertical diagonal line, represents constant speed. Now, since we know those two things, we can then start to think about, well, what happens when the speed is changing. So if an object is speeding up, this line is going to get steeper. So if I compare this from another object, but maybe this time the object goes here, this is also travelling at constant speed, but in the same amount of time, it's travelled a further distance. So the steeper the line, the faster the constant speed. Now when we talk about the steepness of the line, we talk about a key word. And the key word that we use is gradient. So the gradient is just the key word that we use that means the steepness of the line. Now, on a distance time graph, if I have a object that is speeding up, so I have distance, I have time, I have an object that's speeding up, the gradient is going to be increasing. So an object that's speeding up is going to be going further and further each second. So speeding up will be a curve like that. So this object is speeding up. The technical word for speeding up is acceleration. So on a distance time graph, an upward curve represents acceleration. Now that can give us a few other things, because obviously the opposite of speeding up is slowing down. So in that case, what it would be is the line would be getting less steep as time goes on, like that. So that would be deceleration. Just add my distance and my time. So we have these basic shapes. So we've got an object that is stationary, being a flat line, a straight linear line being like this, being constant speed. Obviously the steeper the line, the steeper the gradient, the faster the speed, and then we have a curve upwards being acceleration, and a curve flattening out being deceleration. Now, the next skill that we need to be able to do with a distance time graph is, we've said that these straight lines here are a constant speed, and we can work out constant speed by using the equation that we have in our previous lesson. So speed is distance divided by time. So how I do that, so I'm going to draw a distance time graph. I'm going to be very naughty and not use a ruler. Always use a ruler when you're doing graphs. So I'm going to do a distance time graph, and I am going to have an object that is travelling with a straight line like that. Now, if I put numbers on here, so I'm going to make this distance 5 meters, and this point here 10 meters, and time, I'm going to have 1 second, 2 seconds, 3 seconds, 4 seconds. If I want to work out how fast this object is going, I need to calculate the gradient. I need to calculate how steep the line is. Now, in maths, the gradient is always equal to the change in y divided by the change in x. Okay? So in this particular case, the y-axis is distance, and the x-axis is time. So the change in y divided by the change in x is going to be equal to distance divided by time, which we know is speed. So I'm going to use, because I've got a nice straight line, I'm going to use the two biggest points that I can. So I'm going to go right from up right at the top. So what I do is I use my graph, and where I have my straight line, I just read off, first of all, how tall it is, how big it is on the y-axis. So this particular line, on the y-axis, the change in the y-axis is from 0 up to 10. So it's 10. And then I look at how far it is on my x-axis. So in this case, it's from 0 to 4. So I'm going to do 10 divided by 4. Put that into my calculator, and obviously I will get, change over x, 2.5, and because it's speed, it's meters per second. So that tells me how steep that line is. If I use a slightly different line, we said that if I'd got a steeper line, that means it would be going faster. So if I have this line now, I've drawn in red, so I do the same thing. I measure how tall it is on the y-axis, and it's still going to be 10. And then I measure how far it is on the y-axis, which in this case is now only 2. So it would be going 5 meters per second, which makes sense because we knew it must be going faster. The only way that this can be any more tricky, so to speak, is if I have a graph over here, has multiple parts to it. So for example, I've got my distance time graph, and now what's going to happen is my object is going to be going at constant speed, it's going to be stationary, then is going to travel at constant speed, and then is going to be stationary again. So I'm going to make this 5 meters, 10 meters, 15 and 20, and I'm going to keep my times simple again, 1, 2, 3 and 4, just to make it nice and straightforward. So if I was to try and work out the gradient for these two flat bits, my change in y is 0 because it isn't going up or down on this axis. So these two bits, the gradient is 0, which means the speed is 0, which should make sense because we know that at these 2 points the object has stopped. At this point, when it's going at constant speed, this is the bit I want to work out. So I look at the change on the y-axis, which I can see is from 5 up to 15. So my change in my y-axis is 15 minus 5. And then I look at my change on my x-axis, which is 1 up to 3. So it's 3 minus 1. So you could probably do this in your head very simply without doing the minuses, but I can see the difference between that is 10, and the difference between 1 and 3 is 2. And then, so I'm doing 10 divided by 2. So again, this object is also going at 5 meters per second. This skill of being able to calculate gradients is really important. So we're going to do this again in velocity time graphs. But when you are looking at a distance time graph, remember the gradient is equal to the speed. If you've got a straight flat line, it's stationary. The straight linear line represents constant speed, and the steeper that line, the steeper the gradient, the faster the speed. If it curves upwards, it is accelerating, and if it curves so that the gradient is flattening out, it is decelerating.